Okay, in this video we're going to fill in the notes for 6.4, and we have some vocab that we're reviewing. So a ratio is a comparison of two numbers. So an example of a ratio would be 3 to 4. You can also write it this way with two dots. Okay, a proportion are two ratios that are set equal. Okay, so if you say 3 to 4 equals 6 to 8, that's a proportion. We're also calling those scale factors. When you set them up like that, you can get the scale factor, which is 3/4. Okay, similar polygons, as you already know, they have the same shape, but different sizes. So if it has the same shape, it means the angles are equal. And if it has different sizes, it's going to mean that the sides are in proportion. Okay, so we had a theorem last section, 6.3, was angle, angle. Now we're going to introduce two other ways you can prove that you have similar triangles: side, 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 and side, angle, side. So in side, 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 if the corresponding side lengths of two triangles are in proportion, then the triangles are similar, and that's our symbol for similar. Okay, let's do the next one on the next slide. Okay, so side, angle, side similarity theorem says if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides including these angles are proportional. So this is proportional. Okay, in example 1, they say that we're going to use side, side, side similarity theorem. So is either triangle DEF or GHI similar to ABC? So here's DEF and here's GHJ, I should have said. So let's check this out. So I'm going to try to compare the smallest sides. So 8 is to 6, the medium sides. 12 is to 9, and then the biggest side. 16 is to 12. So let's see, will these reduce? So it looks like everything is going to reduce to 4/3. So these guys are similar. If we test the other ones, so we go small is to small, 8 is to 8, like medium is to medium, nope, not going to work right away. So this is a no, this is a yes. So we can say triangle ABC is similar to triangle DEF. Okay, so let's stop there for a sec. Okay, going on to the next example. We have the following. Find the values of x that make the triangles similar. So they want to make, they gave us the order, ABC, similar to DEF. So how can I do that? It looks like I have to have a value of x. So 4 is to 12, just like x minus 1 is to 18. Okay, so let's try that. So let's do 4 times 18. So 4 times 18 gives me 72. So 72 equals, now very carefully, 12x minus 12. So be careful. 12 is being multiplied by both the x and the 1. So add 12, I get 84 equals 12x, and take 84 and divide by 12, and you should be getting x equals 7. So the answer is x equals 7. There's no need to try to solve for the other one because it's all going to work out the same. So x is 7 is our answer. And let's go on to example 3. Okay, this says you are building a lean-to shelter starting from a tree branch as shown. Okay, can you construct the right end so it is similar to the left end using the angle, measure, and lengths shown? So what they want you to do here is they want you to figure out, okay, could these triangles be similar? So I see that I have 53-degree angles, so that's the angle part of it. Now the question is 6 to 9 just like 10 is to 15? So do your cross products, see if they're equal. Because if they're equal, then you know you're good. So 6 times 15 is 90, and clearly 90 is 90, or 9 times 10 is 90, so therefore I can say by side angle side similarity, these two shapes are similar triangles. Therefore, you can absolutely make GH in proportion to BC. So the answer is yes, you can do that. Okay, so are there any other? Yep, there's 2 more practice problems. So let's do those on the next page. Okay, so here they want to know, is triangle PQR similar to STU, or is it similar to XYZ? So this is the standard, this is the gold standard. Figure out what's similar. So if they're similar, because I'm looking at the shapes, so therefore I'm going to have to test these other two. So how about, look at the longest side. Is longest equal to longest in the same proportion? So here are my proportions. So I have 30 over 42. Go for the middle ones next. 25 over 35. And then go for the smallest ones next. So 15 over 21. Okay, put those in your calculator and see what decimal you get. Okay, I'm getting 0.71 here, and then 25 divided by 35. I'm getting the same thing here, and let's just check the next one. 15 divided by 21. Bingo. So right away, I know that these two are similar. So what can I say in terms of the statement? So go with the sides that are, I guess we'll go smallest. So I'm going to say YZ and then go to the largest. So this triangle is similar. So go smallest to largest. Q, R, and then P. Okay, so that works. So that's my similarity statement. I can check the other one. Can I go, let's see, smallest, so 15 is to 15, well, that works. And then the medium is 25 to 20. Nope, does not work. So this one is not similar. Okay, we have one more problem. We'll do that on the next page. Okay, here we are on our last problem in this chapter. So I have a similarity statement right here. Based on that, they want me to solve for x. So I know that 20 is to 30, just like x plus 6 is to 21. So I'm going that way. So 21 times 20 equals what? 420. 420 equals, very carefully, 30x plus 180. Don't mess that up. This is a multiplication right here. So subtract 180 from both sides. So 420 minus 180 gives me 240. So I'm going to continue up here. So 240 equals 30x divide both sides by 30, and I should get 8 equals my x. Check that for yourself. Make sure you're okay on that. So I've solved both of those now. So I have agreed with the similarity statement, and I have found the correct x. I can now plug that in. If they said figure out all the sides, I know that that side is going to be 14. Plugging in the 8 here, 8 minus 2 is 6. That side would be 18. And now I have all the sides if they had asked me that question.